Calculus Unit 1, Day 3 Notes, Part 3. And I've already given you this answer, but based on our knowledge from pre-calc, we know that if a rational function has a non-removable infinite discontinuity, graphically a vertical asymptote exists. Since the y values do not approach one specific value from both sides at a vertical asymptote, then the limit does not exist. However, we can determine if the one-sided limit approaches negative infinity or positive infinity. In order to do this analytically, we marry the numerical, graphical, and algebraic approaches. For each limit below, determine the sign of the simplified function at the value to the right or the left of x equals 1. We've already gone through and we already simplified. We factored out x plus 3 from the numerator and denominator, so above here, let me just go back to that, for the cancellation process. So we went through and using the same exact rational function, we took out the x plus 3 factors. So this is where the x plus 1 and x plus 1 over x minus 1 comes from, both these. So we're saying, yes, x approaches 1 from the left. So I'm going to choose 0.9. I could choose 0.99, I could choose 0.999, I could choose 0.8, doesn't really matter. We're just going to go to one decimal right now. So what I'm going to do is let's put in 0.9 for every place cx, and then over here for x approaches 1 from the right, again, we're going to choose 1.1. I could choose 1.01, 1.001, 1.0001. There's a bunch of different values I could choose. And every place C and X, I'm going to put in 1.1. Let's do that. Okay, so on this first example, I get 0.9 plus 1, and really all I need to know is that the numerator is positive, and then 0.9 minus 1 is going to be negative. And since a positive divided by a negative is negative, then I know that the limit of the function, down, limit of the function as x approaches 1 from the left must be approaching negative infinity, because I know I factored out, and this is what's remaining. 1 is going to make this, after I use the cancellation process, 1 is going to make this undefined, so I know that's what we just talked about here, the non-removable infinite discontinuity, vertical asymptote. So as I approach from the left, I'm going to go to negative infinity. And now let's check over here as I go from the right. It's going to be a positive over a positive, which again we know is going to be positive. So I know the limit of the function as x approaches 1 from the right must be positive infinity. Okay, so now we have a graph g of x, which is square root of x plus 1 minus 2 all over x minus 3. And they show the picture of the graph. And now what we want to do is just talk about rationalization, and this can be used to evaluate a limit analytically. So find the following limit. Well, the limit of g of x as x approaches 3. Well, if I just do direct substitution and I put in 3, it's going to be 3 minus 3 over 0, which will be undefined. So what I want to do, it's a similar concept to when we had complex numbers and we were using the complex conjugate. So let's do that, and I'll show you how this works. So if you remember from complex numbers, if we wanted to get rid of this imaginary number in the denominator, we would multiply by the complex conjugate of the denominator. Well, kind of the same idea, we're rationalizing, and so to get rid of the square root of x plus 1 minus 2, I'm going to multiply both the numerator and denominator by square root of x plus 1 plus 2. So what we end up getting here is the limit as x approaches 3. Well, square root of x plus 1 times square root of x plus 1 is just x plus 1. The outer and the inner terms are going to cancel out because it's the product of a sum and difference, which will give us the difference of squares. And negative 2 times positive 2 is negative 4. And now we are going to get, and I'm just going to leave it written like this, x minus 3 times square root of x plus 1 plus 2. And we should start to notice that the numerator is going to simplify to x minus 3, and we have that as one of the factors in the denominator. X plus 1 and the plus 2 is not under the radical. So now those can cancel out, and we can now take the limit as x approaches 3 of 1 all over square root of x plus 1 plus 2. Again, that's right there. And now I can use direct substitution, and I get 1 all over square root of 3 plus 1, which is 4. Square root of 4 is 2, plus 2 is 4. So it equals 1/4. So as I can now find, because it's not continuous there, it's a whole, but I could find out using um, using the rationalization, which now I can then just direct substitute, because I know, I'll write this down, it's going to, the limit from the left is going to approach the limit from the right. Okay? And that's it for part 3.